Hi guys, I came across a few videos on YouTube showing how to design a Darth Vader helmet in Blender, which is CAD software for graphics design. And it got me thinking if this model could be created in SolidWorks. So I've been playing around with surface modeling in SolidWorks lately and wanted to see what I could do. So what I've got here is the final model I created of the Darth Vader helmet. So it's not perfect, but it's pretty decent. And this model could actually be 3D printed, which I might do at some stage. If somebody has a 3D printer, I'd be happy to send you the STL file and you could have a go at printing this. So this video is just going to be a rough overview of the design steps I took to make this model. And if you want, let me know in the comments below if you'd like more detailed videos, which would be a bit longer going through the exact steps. But I'll quickly run through what I've done in this video. So this final model is consisting of quite a few different steps that we can see in the design feature tree. So I won't have time to go into detail of everything, but we'll see how we go. So to start with this model, essentially the first thing you need to start with are some blueprints. So I just did a Google search of Darth Vader blueprints. I got this image, which I cropped, and I also found another side view image. And then when I started my image, you just create a sketch to start on the front plane, for example. Go into Tools, Sketch Tools, and Sketch Picture. And then from there, you can select the image to import in. And you can change the size of this image to whatever size you want the model to be. And you can change a few other parameters, such as the transparency. So just delete this. So I'll just be running through the design tree steps. So essentially, I imported a front view image and a side view image. So these images aren't actually from the same blueprint, so they're slightly different. They're actually slightly different models, and I ran into some problems later on with that because not all the features align perfectly. So you kind of have to use your intuition and just do the best you can when you don't have exact front and side view blueprints. So essentially, once these are imported, you can start creating your surfaces to make the model. So I'll just run into the first surface. So the first surface I created was this feature on the helmet. You can kind of create this in one large surface. So essentially I used the surface loft feature predominantly. You basically have two options with creating complex surfaces, and that's the surface loft feature, the lofted surface, or the boundary surface. In my case, I tend to find the lofted surface feature to be a bit more versatile. For example, the boundary surface feature tends to need 4 sides, whereas the lofted surface feature can work if you only have 3 sides. So essentially what you do is create a 3D sketch. And essentially your bread and butter of surfacing is creating 3D sketches and then using splines to create the boundaries of your surface. And essentially you want to try use the minimum amount of surfaces, but you don't want a surface that's too crazy, too complex, because it's just, you're not going to really capture your design intent. So for example here, I've added quite a few 3D splines here, and I might just hide these. I won't hide them just yet actually, but essentially this spline, for example, I've followed one of the edges on the blueprint models, and there's quite a lot of back and forth of changing these spline handles to get it to fit what you want. So for example, I'll kind of copy it in here. If I wanted to add a spline that mimicked one of these curves, I would click a point there and then another point there. Then you'd go into this spline and change these spline handles so it follows the curvature in your blueprint. And you have to do this in either a front view, a top view, or a side view perspective, because what you do is you kind of switch back and forth quite a few times to really get that curvature matching your images. So I appreciate it's a bit difficult to see exactly what I'm doing here with all these other splines in the way. But essentially you just draw splines and get them to match the shape of your blueprints. Now, as I talked about earlier, the blueprints I use don't exactly match. So you'll see in this area here, this line kind of isn't really matching this bottom edge of the helmet. And that's kind of where you have to use your intuition to basically choose one or the other blueprints to follow, and to just I mainly use the front blueprint and just use the second one for rough surface kind of shapes, but I didn't exactly follow the edges. So once you've created your rough outline of the first section you want to make, so I'm starting with the helmet in this case, I created this 3D loft. And in the 3D loft, you choose two profiles. So my two profiles are these two blue lines. And then you choose some guide curves. So I used 3 guide curves, which were contained in that initial sketch. And this helps kind of define the surface that you're trying to create. So essentially, if I now hide these blueprints, you would see that we've created that first initial surface. And this is a 0 thickness surface, so it's not actually a solid model just yet. So I'll put the blueprints back on. And then the second surface I created was the bulb section of the helmet. And it used that initial 3D sketch that I created to start with. So in that lofted feature, my profiles have been these two blue lines, one which is the edge with the first surface created, and one which is an edge that is on a plane parallel to the right view plane. And in this case, I've used these purple lines as the guide curves, and I've actually chosen them as a group. So sometimes with these surface tools, if I were to select that edge, line as a guide curve, and then this one, it kind of doesn't work. So if I try to rebuild that now, the loft operation failed to complete. So sometimes you need to play around, and essentially what you can do is right click and click Selection Manager. And then that will pop up with this box which has a few useful options, and you can select a group of lines. So apologies, that sketch is hidden, so I'll just unhide that. So I'll go back in. So I'll delete that. Okay, back to where we were, Selection Manager. So I'll select this, and then I'll click OK. And it's bundled those guide curves up into one package. I'm not exactly sure why that allows you to then build a surface, but it has to do with the underlying mathematics of what's going on. Just to quickly demonstrate the Selection Manager, the other options. So if you had a chain of curves that were acting as like a profile or a guide, you could also select the open loop. Or if in a different case, maybe a different surfacing tool, you could select the closed loop to select your features. So I'm just going to close this. So what I'm doing here is I'm not actually building this as we go. I'm just demonstrating the steps I've already done and trying to give examples of them. This model did take quite a long time to design, so if I were to do everything from scratch, it would be quite a long tutorial. So just quickly going through it, so then I created a plane. So after I'd created these two surfaces, I created a plane here. And because I had drawn this curve parallel to the right plane, I could then come in and create a plane by selecting 3 points on that curve. So this bottom one and these two up the top here. And I did that to then create another surface, which is this kind of ribbed feature here on the helmet. So occasionally you want to look at an actual model of what you're trying to create. So if you just, for example, I just Googled a Darth Vader helmet, and there's this kind of rib that goes over the helmet there. So if I go back into my model, what I did is I created plane, then I created another sketch, which basically offsetted that edge, so that when I create a surface there, it creates that first rib. So for there, I used a different tool, and I just used the surface plane tool, which is great if you're just trying to create a flat surface on a defined plane. You can generally have any enclosing boundary to create that. So with surfacing, it's kind of important that you use the right tools for what you're trying to achieve. And by no means am I perfect, so if anybody notices a more efficient way I could have done things, please comment below. And then finishing off this helmet, I did another surface loft of the top part of that rib feature. So I created another sketch. So what I did here is I did a sketch on the plane intersecting through the middle of the helmet, and I essentially just converted the entities. So converting entities just means using old edges or edges in previous sketches to create new lines in the current sketch. And I also had a 3D sketch here, so I'll just can't remember exactly what that. Oh, so yep. So that 3D sketch is just these lines here bonding the two edges together, like that. So then once I had those edges defined, I then did another surface loft feature where my profiles are these two blue lines and my guide curves are these purple lines here, which I just demonstrated. So the way I created this model was to do half at a time and then mirror everything at the end. Generally, if you've got a symmetrical surfacing model, that's a good way to do it because you can significantly reduce the amount of surfaces you need to actually create. So after I had the first half of that helmet section created, I went into the face and the neck. So this was actually quite complex to create. So what I had to do is break the face up into multiple different surfaces. So using the same technique of creating a 3D sketch and using a bunch of 3D splines to mimic the edges on the blueprint is where you start generally. So I did draw a whole bunch of splines, manipulated the spline handles to get the curvature I wanted. You went back and forth between the front view and the side view to get that specific curvature. And that can be a tricky process. I might demonstrate that in a later video, how you can actually get the desired curvature. So I'll just exit this sketch. So undo what I did there. And then it's the same principle. I used that 3D sketch I created to use the surface loft feature where I've chosen two profiles, these blue lines. And then I've chosen guide curves again to create my surface. So the first surface I just arbitrarily started with was the section under the eye. And I don't really have time to go through all of these, but I then created a surface feature for the area above the eye. To do that, I probably at the time made that surface hidden, the surface on the helmet, so I could easily see what I was doing a bit better. Just hide that sketch. And then just quickly going through this, I created another surface there, just around the nose area, another one there. Here, you find yourself, you sometimes have to create planes, so to help with your modeling. So I created a plane there which mimics that front facial edge. And I did that there to create that surface, which is part of that mouth feature. And just quickly going through it. This is probably just me kind of being inefficient. These surfaces didn't match up just here, so I had to create another ruled surface and then trim that surface there back and kind of delete that ruled surface that I'd created. Essentially, those steps were just to get these to end on the same plane so that I could stitch them together a bit later. There definitely would be a more efficient way to do that, but yeah, this model isn't perfect. Then I actually came in just there with the surface fill feature, which is another good surface tool, which is useful if you have a boundary defined by some edges. It doesn't necessarily have to be a flat plane, but just any kind of boundary, and then it just automatically fills. So I might just quickly demonstrate that. So these edges were selected, and then the tool will automatically fill that area with the surface. So another surface was created on the nose section there. So these are all using the same principle of creating a 3D sketch, manipulating your spline handles by following your blueprints to get them to follow the desired curvature, and then using the surface loft tool to create the surface. Now, if you want, you can experiment with the boundary surface tool. It is another powerful feature, but I just generally prefer using the surface loft. Moving forward, another surface there for the bridge of the nose. Now, this section here, if we look on the Darth Vader model, these sections along the cheek are kind of circular sections or semicircular sections that run along the face. So to create them, I did a bit of a different process. I created a circle. I drew a sketch of a circle following my blueprint. Then, generally for a surface sweep feature, you create a profile, which in this case is the circle, and then a sweep path. So I didn't actually create a sweep path. What I did was coming into the surface sweep feature into the path, section. You can right click and use the selection manager again. And here's an example where you would use the select open loop. Actually, no, not in this case. You would select multiple edges, a group. And that way you can use existing edges to define your path. So we can see there that it's created a hollow cylinder running along the edge of the face. I also used that to create, if we look back at the images, two kind of semicircular sections. So in this case, because I didn't have those edges to work with as the path, I actually had to come in and create a specific path sketch. And essentially what I did again is create a 3D spline and use the blueprints to define the curvature. So here we can see it actually doesn't really match up with the blueprints at all. And sometimes, you can have some fun with what you're doing and try to be a bit creative and use your own imagination to define the shape of paths and splines and surfaces. You don't have to 100% exactly follow blueprints or images. Now, an issue we have here is that these are cylinders and we kind of want them to be semicircular. So what I did here, I won't go into great detail with this because it will take up a lot of time, but I used the surface trim tool. So the surface trim tool allows you to select intersecting surfaces essentially. So in the tool, I've got a trimming surface plane or sketch, and then I've got a surface to be trimmed. So I'll just quickly go above that. So we can see here that it might look it's a bit difficult to see here, but we have this one cylinder coming up here like this, and then this other cylinder going in a slightly different direction. And what that does is it creates some intersecting surfaces that we don't essentially want. We kind of want a hollow channel path between two. So I used that surface trim tool, and then I used it again because there are multiple surfaces in there to hollow out that area, kind of delete those intersecting sections. And then I use the surface loft again to fill that area, just like that. And then I started creating the neck using the same feature of 3D splines and surface loft tools. So I think, yeah, I briefly touched on that a bit too early before about the trimming these cylinders kind of into semicircular shapes. But essentially I started doing that here. So it probably wasn't actually the most efficient method to do it this way, by creating these cylinders, because I had to do a lot of work where I started using the split line feature, which essentially adds a sketch onto surfaces that are intersecting. So the reason I did that is because I had to create a parting line essentially between where, say, this cheek surface and this cylindrical surface are meeting, so that I could then use the delete face tool. So I might just hide that blueprint to just demonstrate there what I did. Possibly I can get a better view. Might be able to get a better view from this angle. So I had the cylindrical surface, and we're looking at the inside of the face now. And we don't want this inner part, inner surface to be there. We want it to be roughly semicircular. So using the split line, where I'm using these intersecting faces, I can create sketches, and then I can use the delete face tool to delete away that inside part. So we use the split line because we have to define how we're splitting that surface up so that we can then use the delete face. Essentially, we're splitting one face into multiple faces and then deleting away the ones that we don't want. So that process was repeated as well for this cylinder down here. Just quickly jump through just there. So I think it's roughly easy to see what's going on. You've got your cylindrical surface, and using split lines and deleting away the face. Using some more surface trim tools, and then a few more lofted surfaces. I think I just created the eye there. So I created the ridge underneath the eye, inside of the eye, and then the actual eye lens section. So I splitted these up into a few different folders. So that was the face and neck. Now I had to merge the face and the helmet. So I had hidden that first sketch that I did, so I'll just show that again. I might hide the other blueprint, don't really need it at this point. So at this point in the design, the goal is to essentially create a solid model of this Darth Vader helmet. And generally, to do that later on, we use surface knit, where we knit all our surfaces together and then create a solid. And the solid is created when we kind of have a shell of surfaces. It fills the inside essentially. So at this point, I had most of the face down and the helmet down. So what I decided to do is just connect the edges of the face up into the inside of the helmet on that edge there. So I'll just quickly go through that using the same method. I created there surface that bonds the face to the helmet. Another surface there, bonding that. A few more, and then a couple more. So again, that may not be the best way to do it. And if we actually look at our Darth Vader helmet, the actual real model, the face section is separate from the helmet section. So it's really meant to be something like this. And then the helmet part is, or the cap part is another piece that attaches to that. That is a bit more complex to model, and it's not really what I was trying to achieve in modeling this. If you wanted to try design something like that later on, by all means go ahead. But what I did here is essentially just make it one piece and connect the face to the helmet. Moving down into the next folder. Here is where I mirrored the surfaces and knitted them together. So did another split line here. What was that? Okay, so I believe I had some challenges here. Let me just... Okay, so that's just a surface fill of this open cylindrical end. So like I was saying before, with the knit surface / create solid tool, you need the whole area to be encapsulated with surfaces. You don't really want any open sections. So initially, this first knit, I tried. Now sometimes the surface knit tool won't knit everything together in one go, I've found. I think I had to break it up into a few different sections here. So I think what I did is I knitted the face and the crown of the helmet together first. Then I knitted this. Actually, I'll just go into this feature to see what's going on. So just to select all that. Yeah, so these blue highlighted surfaces are the initial ones I knitted together. So yeah, I think the software was having trouble knitting this grey surface of the helmet, now orange, surface with everything else into it. So I found, yeah, if I did this, it worked. If I knitted all the face and the top of the helmet together, then I did another knit feature and I knitted these edges of the helmet onto the new large surface. It worked. So in this first feature, we can see that there's a whole bunch of surfaces here. I know, about 20 surfaces there. And when you knit them together, it essentially becomes one surface, like one essentially pretty complex surface. So at this point here, if I look under my surface bodies, I've got two surfaces essentially defining the model. I then did a mirror. So the mirror, you just choose the plane you're mirroring about. So I mirrored about the right plane and mirrored those two surfaces. Then I did a surface knit. And in this surface knit, I merged the two halves together. Because when you mirror one surface, you then have two surfaces. So at this point here, I'm preparing to create a solid feature. So if I actually do a section view now, this thing's not solid. So I did a surface fill of that front face section to kind of encapsulate the design. then another surface fill of the bottom neck part, just there. Then surface knit feature, where I knitted. Here I believe I'm knitting the face and the helmet to the other edges of the helmet. Another surface knit. Okay, and in this section here, yeah, I just knitted all the helmet sections together. So yeah, I had some difficulty with this part because sorry, just going back a couple steps to clarify. So I might hide that for now. So here I did a surface knit of the whole face and the whole helmet, and I ticked this box, create solid, because I had the whole area encapsulated. And then what that did is added material to the inside to then create a solid model. Not it's no longer like a series of surfaces with zero thickness. You see that there. Then what I had to do is give this helmet section here some thickness. So I couldn't use this part in the create solid step because there's no kind of encapsulated area. It's just kind of a floating surface. So you're not really giving the software enough information, telling it what it needs to do exactly. So the way I did this was I knitted all those floating surfaces to the rest of the body. Just hidden one before. Whoops, didn't mean to hide that. Hide. So yeah, I knitted the helmet surfaces that were kind of floating, all these surfaces here, to the rest of the body. And then I did use the thicken feature. Now, I had a bit of a problem with this step as well because the thicken feature is a surfacing feature in the surfacing toolbar and gives some thickness to your zero thickness surfaces. So what I wanted to do is you can choose three options with the thicken feature. You can thicken in the direction of one side, or you can thicken in the direction of two sides. You can maybe see that a bit clearer there. Or you can thicken in the direction of the other side. Now, because I'd used the blueprints to create a rough trace outline of the surfaces, essentially what I wanted to do is thicken in towards the inner direction, like thicken inwards towards the helmet. But when I tried to rebuild that, it wouldn't do it and it gave me an error. And that's essentially because you're creating thickness which is now intersecting the rest of the model. So it doesn't really know how to handle that. So my only option was to thicken in the outwards direction, which isn't a massive issue, but it just roughly changes the initial design intent, the initial geometry that I was aiming for. Now I've kind of gone with 5mm here, which is quite large. If this were a plastic, it could easily be 2mm. But because the size of this model is quite large, it's roughly 30 centimeters from the top to the bottom. If I want to 3D print that, I might scale it down to maybe a quarter of that size. And if I'm scaling down the thickness of this floating helmet section, for 3D printing, the minimum thickness I can probably print is 1 to 2mm. So I made it 5mm so that if I print a quarter size divided by 4, it should roughly be okay. But the good thing about parametric modeling, where you have a design history, is that I could go back in and I could then make that 8 millimeters thickness, and it'll just rebuild like that. So then to finish off this model, I added in some facial features. So looking at the image of the Darth Vader head, you've got these kind of chrome colored sections protruding out, and you've got some grid patterns and some slits in the nose bridge section. So they're features that can easily be done on a solid model, so that's why I left them towards the end. So just quickly running through them. I started by creating a plane, and then using that plane to cut out a section in there. Then using a sketch and the boss extrude to create the rough pattern inside there. Doing some more features. I think I was just cutting away some excess. There I cut away that nose hollowed out section there. Use the fillet tool to smooth it round, which we can see it's kind of smooth in that image there. Boss extrude to extrude out these features. You can see there. Revolve to create that feature there. Then I mirrored that to duplicate it on the other side. What did I just do there? Cut extrude. So essentially I did a sketch looking roughly like that, made up of a whole bunch of splines, and then I extruded cut through all to create that nose bridge feature. Some more fillets around the neck. So this neck section I didn't model that well, to be honest. If we look at it here, there's some kind of sharp edges, which on a good model that you just don't see that. It's kind of smooth, but yeah, I couldn't really be bothered spending too much time to try and make that perfectly smooth. So I just added some quick fillets to smooth it out a little bit. Finally, I created a plane there and cut extrude into there and boss extrude to create that pattern. So that's all the features of this Darth Vader helmet. An important step is to then add some appearance to the model. So I'll go into high gloss plastic, make the whole model high gloss plastic, and maybe go into metal, chrome plate. Might want to make that surface. I suppose that mirror feature, chrome plate, and that mirror feature, chrome, that revolve there. So this is fairly straightforward to do. You just click and drag an appearance onto the surfaces you want to change and then go through it. I'll just open up another model where that's all done. You can switch between shaded with edges and shaded without edges mode. So that's with the edges. I might just quickly demo that in the grey color. So that's with all our surface edges present, and then shaded without, it looks like that. So once you've got your appearances in place, you can create a render. So if you've got Photo View 360 installed, which basically you should have, if you're running SolidWorks, you should have that option available. But it doesn't always load at startup, so you can go into Tools, Options, okay, Okay, I'll have to show later how to add the Photo View 360, which gives you these render tools in later. I might do another video on that. But essentially, you can then use these rendering options to make a nice presentation quality, like realistic image of your design. So in this Display Manager section, you can play around with the scene. So I might edit the scene, which you can also do over here. Just like you can edit appearance, you can edit the scene. Might choose a studio scene. Yeah, you got a few different options there. Try traffic lights scene. Then you can add some light. So if I right click this directional light and say on in photo view 360, then edit lights, I can kind of drag around this light, and that's going to affect the areas that are illuminated when I create my render. I might turn this one on as well and edit that. Do that as well. Also, to get some more perspective, you can add a camera. So you just right click and edit camera, and then here it's showing the view the camera has of the model. So I can manipulate that there, or I can just go over to the right here into the camera view. And yeah, that just gives us a bit more perspective on the model, which you may or may not want for your rendering. So you can just scroll to the suitable position, click OK. Actually, I might have to have that open for the rendering. And then I'll click Final Render up here. I might make another video later on going through some of the rendering details and how to play around with some of the rendering options. Rendering can take a while to complete. It's pretty CPU and GPU intensive, so you just have to be patient while it's rendering. So just while we're waiting for this to load, I can show you some renders that I've done of this model. So there's one which looks pretty decent. There's another model, and another one. So this kind of stuff isn't exactly what SolidWorks is designed for. It's more for like as you probably know, like engineering-based design, design for manufacture. But the surfacing in SolidWorks is pretty powerful, and you can kind of design some pretty complex things, some organic surfaces and shapes with it. So if anybody has noticed some errors or inefficient ways I've done things, please comment below. I'd be interested to get some feedback. And I hope this video has helped demonstrate what you can do in SolidWorks and give you some idea of the things you can model and general steps you can take to model surfaces and helmets and whatnot. So this render here looks pretty crazy because we went with that traffic lights option. Could then go in and change do some image processing on it to make it look a little bit nicer. Around with that. And yeah. So there you have it, modeling Darth Vader in SolidWorks. Thanks for watching. Bye.